Okay, so over break, there's going to be demonstration 2.0, concept check 1.2, and concept check 2.1. Wait, 0, 1, third version, second version, first version. Okay. That way you can get your money's worth, right? By taking lots of well, there's about 10 minutes left where I could go over something if you have the stamina to listen. What kind of problem do you want me to do? Doesn't matter. Let's see. Oh, okay. So let me give you, let's see. R equals there's a space and let's see. Let's say I gave you the set S that was one. Let me see, how about this one? 1, 2, minus 3. Okay, these vectors are in this set because they have to have 1 plus 1. They have to add up to 0. So this is 1 plus 1 is 2, 2 minus 2. And this is so these are so S is a subset of R, but is it a basis? Is S a basis of R? You might have an intuitive idea, right? And then one way to maybe solve this problem would be because you have to sort of take there's several different ways. But let's say what you want to do is you want to say if S is a basis of R, I should take any vector in R and write as a linear combination of things in S, right? So we need an arbitrary or typical vector in R. So what does that mean? Well, the thing is we have this constraint here. So we can go ahead and parameterize R by solving X equals minus Y minus Z and write R equals minus Y minus Z YZ such that Y and Z are any members of R. So we've written this as a span, right? So that what that means is that R is all the set of vectors that look like this, right? So we just take one of these and ask, can we write it in this basis? That would be the same thing as saying A times 1, 1 minus 2 plus B times 1, 2 minus 3 equals minus Y minus Z, Y, Z. And I have to be able to let Y and Z be any numbers, right? So we can treat these as as constants, as you've chosen these numbers and we want to find A and B, right? Well, we can write down, this is the vector form of a linear system, so we can immediately write down the augmented matrix for the system. And solve it for A and B. Okay? Augmented matrix. Well, we don't have to worry about these. We just want to make this into echelon form, the coefficient matrix, so we can do minus row 1 plus row 2 and 2 row 1 plus row 3 to give 1, 1 minus Y minus Z. And so it's doing minus row 1 would give minus 1 plus 1 is 0. And minus 1 plus 2 is 1. And minus this thing would be Y plus Z plus Y. So that's 2Y plus Z. Okay, then this one here would be would be 2 times, well, plus 2 times 1 is 2 plus minus 2 is 0. 2 plus minus 3 is minus 1, right? And then this would be minus 2y minus 2z plus z would be minus 2y minus 2z plus z is minus z. Okay. And then the last one I could do would be row 2 plus row 3 to get 1, 1 minus y minus z, 0, 1, 2y plus z, and then 0, 0, and then this is 0, right? So that's echelon form. And we can take the second equation and say, well, b equals 2y plus z, and a plus b equals minus y minus z. So a equals minus y minus z minus 2y minus z. And so that equals minus y minus 2y is minus 3y, and minus z plus z is 0. So it's just a is just this, I think. Okay, so you can choose any y and z and you have an a and a b, right? So that means any vector in R can be written, any vector in R can be written as a linear combination of these vectors. So include, therefore, R equals span of S. That's a little bit different. The similar problem would be just find a basis for R, right? If I said find a basis for R, you do this and then contribute and get minus 1, 1, 0 and then minus 1, 0, 1, and you could find a basis for R here. You could also solve this problem the second way. Instead of doing all this, you could say, well, look, I'm going to find a basis for R and then ask, can I write each of those basis vectors in this vector here? Right? So there's actually a way you could convert into two problems of could I write the basis elements of R in terms of this other basis? But that would be like changing the basis, right? That'd be like saying, okay, I would find the representation of one, I would find, can I represent each of the basis vectors in R in terms of S, and then because anyway, I'm not sure if that makes sense, but this is sort of the way that we've sort of thought of it before. Take an arbitrary vector in R, write as a linear combination of these two. Okay. Well, now you're really tired out. At least I'm tired out. So hopefully, you will have a good time over the break. And I will have office, and do if you have some, I can put